How air handling units work and how they're built. In this video, we'll be learning how air handling units work within various commercial and healthcare buildings. We'll show you how custom air handlers are built with a selection of various options such as humidifiers, heat wheels, heating and cooling coils, dampers, UV lighting, and the various types of fans being used. We'll explain the different types of air handlers used, including VAV, CAV, dual duct, multi-zone, and 100% outside air units. The main differences between an air handler and your typical air conditioner is that the air handler doesn't provide the source for heating or cooling. Also, air handlers are available in much larger sizes up to and over 400,000 CFM. Air handlers allow greater customization to fit project specifics. The air handler will do its cooling using chilled water from a chiller or refrigerant from a remotely located compressor and do its heating using heating hot water or steam from a boiler. An air handler has 4 possible air systems, which include supply air, return air, outside air, and exhaust air. As you can see, the return air system has 2 options. It can return air back to the inlet of the supply, or it can exhaust the air outside. The rest of the air systems only have 1 option, as shown by the directional arrows. Let's build a custom air handler like the manufacturer would using the engineer's project requirements and the available air handler sections. The air handling unit manufacturer will use their software program to assemble a unit based on the project specifics. Looking at a screen of options, the air handler's engineering team will start building the air handler, maybe starting with the inlet options. Okay, now using the manufacturer's software, we can build a air handler for an operating room. First thing we'll need is the inlet from the outdoors. We'll have a damper with an actuator, and the first section will be our pre-filter section to clean the air that's coming in. And then we'll have our supply fan. This is what will suck the air from the outdoors and push the air into the operating room. Then we'll have a hot water and chilled water coil to temper the air. And finally, we'll have a HEPA filter to clean the air, because there's additional requirements for the operating room. Since you're cutting people open, the air has to be super clean. And then on the exhaust side, we need an exhaust damper and an exhaust fan to take the air from the room and exhaust it out. Now we'll take that air handler that we've built and put it in the actual room. The contractor will set it into the mechanical room in the hospital. You see we got our 2 operating rooms there. We'll set our air handler that we just built, and then the contractor will run the main ducts, the exhaust and supply mains, and from there they'll tie in the branches through exhaust and supply valves, feeding the operating room with laminar flow grills and low return. And then we have our second operating room with the same exhaust and supply valves, same high ceiling supply, laminar flow across down over the body to keep the germs and everything down and out low, exhausting low. And then the contractor will drop in a boiler, hook up all the hot water piping to our hot water coil, and then connect from the chiller to the chilled water coil. Or if you're using a compressor, you can run your DX lines. And on the heating hot water, if you're using steam, you can run the steam lines. Now we'll upgrade the fans. We'll put in plenum fans because they provide better acoustics and allow for some redundancy in case a fan burns out. As you can see, we added them on the supply inlet and on the exhaust. Since this is an operating room, we'll add a UV ultraviolet lighting system to kill any bacterial, viral, or fungal organisms in the air and on or near the cooling coil, including the drain pan where water accumulates before draining. Next, we'll add an energy recovery wheel to save energy and capture the heat that is being wasted. Using 100% outside air is energy intensive, as we are spending energy to cool the air, and then we exhaust all of that air out of the building. To capture this energy, there are several choices like the heat recovery wheel, heat exchanger, or a runaround coil. We'll explain these in another video. We also added filters on the exhaust stream to keep the energy wheel clean. So as you can see, our air will enter the outside air damper, go through the pre-filters, and then through the energy recovery wheel where it will recover energy, through the fan, into the coils, and then the UV lighting system will kill the germs, and then it will go through the final filters, the HEPA filters, before it enters the operating room. Coming back from the operating room, we'll exhaust the air through the filters, through the fans, and then capture some of that energy in the energy recovery wheel, and then through and out the exhaust dampers. This is a dual duct air handling unit that provides cold air and warm air to travel down two different main supply ducts to dual duct VAV mixing boxes. After the dual duct mixing box, the air leaves in one common duct with the correct mixture of cold and warm air to satisfy the temperature setting of the space. The air handler supplies air over the cooling and heating coils simultaneously, and the dual duct boxes decide how much of each to open depending on the requirements of the room temperature sensor. One dual duct mixing box could be providing cooling while another is providing heating. This is a multi-zone air handling unit. Each of the zones has a hot and cold deck damper at the air handler unit, which is different than the dual duct air handler we just showed you. Each zone has its own supply air damper at the heating coil and another at the cooling coil. This air handler has a mixing box that allows for return air and outside air to mix. The outside air damper will modulate to maintain the minimum amount of ventilation air as required by code. It's possible to control the outside air using a CO sensor in the space being served by this air handler to allow for energy conservation. This is another version of the multi-zone air handler, except instead of a dual duct system with two coils in the air handler, this unit uses only a cooling coil. The heating, if required, is provided by an in-duct reheat coil. Here is a variable air volume VAV air handler mounted on a roof. The VAV air handler is probably the most common system used in medium to large commercial buildings. This custom air handler starts with the return air section, then travels through the return air fans. The air next enters the economizer section, where the air can be exhausted out of the building or returned to the system. The next set of dampers is the outside air dampers that work with the economizer to bring in code-mandated ventilation air. As the outside air damper opens to let more ventilation air in, the exhaust damper will open approximately the same amount to let air out. Economizers save energy by using the outside air to cool down the building when the temperature is lower than the return temperature or some set value. Next, the air enters the filter section to clean the air. Various quality of filters can be used depending on the cleanliness requirements of the air. Next, the air travels through a humidifier to add moisture to the airstream before entering the coil section and then through the supply fan that will push the air through the ductwork to the VAV boxes at each zone. The VAV boxes will open and close their damper to satisfy the temperature in this space. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.